Welcome to my channel. So in this video we're going to observe the relationship between the roots and the coefficients in a quadratic equation. So normally for a quadratic equation the solution has got two roots, or is always in terms of two. So for example, a quadratic equation according to the quadratic formula, x will be given by minus b plus or minus the root of b squared minus 4ac over 2a. So literally this has got two parts. There's the positive part and then there's the negative part. So we can split those two so that the one with the positive here, we call that alpha. So that alpha is equal to minus b plus the root of b squared minus 4ac over 2a. And then we can also take the case when this is negative and we call it beta. So your beta is equal to minus b minus the root of b squared minus 4ac over 2a. So these are the roots that we're talking about. So we're going to look at that relationship with the coefficients of the standard quadratic equation. So we are going to look at them in terms of the sum of the roots and the product of the roots. So let us do that. So let us start with the sum of roots. So the sum of roots is just alpha plus beta. So in this case we're just going to take the two and add them. So we have minus b plus the root of b squared minus 4ac over 2a plus minus b, add this one here, minus the root of b squared minus 4ac over 2a. So if we add these two together, the numerators are the only ones that are different, but the denominators are the same. So we're just going to have minus b plus the root of b squared minus 4ac. Then this is plus minus, that is minus, so minus b minus the root of b squared minus 4ac, and that is over 2a. So if you try collecting the like terms, we'll find that we take minus b, we're going to get that to be minus 2b. And then we take this is positive value, then this is negative. So it is like we have the root of b squared minus 4ac minus the same thing. So we get a 0 there. And still in the denominator we have 2a. So if we simplify this, 2 and 2 will go, so we are going to be left with minus b over a. So this therefore implies that the sum of roots, that is alpha plus beta, is the same as minus b over a. Then now let us look at this in terms of the product of roots. So according to the product of roots, that is alpha times beta. We're just going to take the two roots, alpha, then we multiply by beta. So that will be alpha, we have minus b plus the root of b squared minus 4ac over 2a, and then we multiply that by beta, which is minus b minus the root of b squared minus 4ac over 2a. So when we look at this keenly, we are going to realize that it looks like something from the quadratic identities, just the numerators. You have minus b here, you have minus b here, and you have the value under the root, and it's the same the other side. The only difference is that this is a sum and these are different. So if you compare that with the case of a quadratic identity where you have a plus b times a minus b, it is the same situation, and normally this gives a difference of squares, that is a squared minus b squared. So this is what we are expecting to happen in this case. So it therefore means that alpha beta will be a squared. So a in this case is minus b, so we are going to have minus b squared minus b squared, and our b in this case is the radical, so that will be b squared minus 4ac under the root sign squared, and then the denominators are the same, so 2a times 2a, that will be 4a squared. So let us simplify the numerator. So minus b squared is just b squared, then this square will cancel the root sign, so we're going to have minus in bracket b squared minus 4ac, and that is over 4a squared. So let us open up that bracket. So we're going to have b squared minus b squared, and minus minus, that is plus 4ac over 4a squared. So b squared minus b squared is 0, so it means therefore that we just left with 4ac over 4a squared. So 4 and 4 will cancel, then a will go here once, a will go here 8 times, so we're left with c over a. So it therefore means that the product of roots is given by c over a. So now we can compare the sum of roots and the product of roots with the standard quadratic equation, that is ax squared plus bx plus c is equal to 0, where if you want to get the product of roots, you just take c over a, and when you want to get the sum of roots, and that is alpha plus beta, you just take the negative b over a.